Okay, in this lesson, we'll take a look at concentration. Concentration is a way of describing or quantifying, of putting in numbers, the characteristics of a solution. Remember that a solution contains a solvent and a solute, which is dissolved within the solvent. Typically, in most solutions, the solute is a solid or a gas, and the solvent oftentimes is water. This isn't always the case, but usually it is. And in this lesson, we'll be dealing with these kinds of solutions. And most often, the solvent is water. Water, because it's polar, is very good at dissolving things. Now, if we take a look here, we have different ways of measuring and quantifying or putting into number form the concentration of a solution. Another way to think about concentration, it describes how much solute is dissolved for every unit of volume in the solution. The first way of measuring and expressing concentration is to use molarity. Now later in the course, later in the class, you'll learn more about the mole and what it is. For now, just know that the mole is a way of measuring mass. Molarity is quite simple. You take the moles of solute and you divide it by the liters of the entire solution. And that's a standard thing. You know, all chemists agree that when we talk about molarity, abbreviated with this uppercase M, molarity is defined as moles per liter, and that would be your units. So here's an example. Let's say we have 5 moles of a substance, and those 5 moles are divided in 10 liters of solution. So 5 divided by 10 would give us 0.5, and that would be the molarity. So the molarity, the concentration of that solution, or I should say the concentration in molarity would be 0.5 molar. That's how you would say it. That's how you calculate molarity, moles divided by liters of solution. Moving on, we'll look at mass per unit volume. This will vary depending upon the units that are used. Typically in chemistry, as you see here, we'll see grams per milliliter or grams per liter. So for every unit of volume, this is telling us how much mass, usually in grams, is in that unit of volume. So again, looking at an example here, let's say we have 200 grams of X, whatever X is, chemical of some sort. And let's say we have 600 liters of solution. So if we divide 200 by 600, we get 0.33. And I'll round that. That would be 0.33 repeating. But we have 0.33, and that would be grams per liter. So that tells us that in every liter of solution, we have 0.33 grams, or about 1/3 of a gram, of compound or chemical X. That is not a very high concentration. We would call that a very dilute solution. Okay, let's look at another way of measuring concentration. This is something called molality. This is abbreviated with an italicized lowercase m. Molality is similar to molarity. The difference is we're dividing not by the volume of the solution, but by the mass of the solvent that's used. So molality is moles of solute divided by mass of only the solvent, and the units would be moles per kilogram. Molality is useful if we have very large changes in temperature of a solution. The volume can actually change of a solution. It can change as the temperature changes, and this would affect molarity because we might have more or less volume. This would not affect molality. So here's an example. Again, let's say we have 10 moles of compound X, and that 10 moles is divided in 5 kilograms of water. So that would give us a molality of 2. And of course, that would be lowercase italicized m. So that particular solution would have a concentration of 2 moles per kilogram of solvent. So that's molality, and that's how you calculate it. We have a few more here. Another one is called parts per million. And an easy way to calculate this is to take milligrams of solute and divide by kilograms of total solution. And we can do this because a kilogram is 1 million times larger than a milligram. And remember, think back to the metric system. We have, the stepladder method. That's in a previous part of the course that's described to you. The difference between milli and kilo is ends up being 1 million times. So if you divide milligrams by kilograms, that gives you parts per million. To visualize parts per million, if you have a solution, and if you could divide it into 1 million equally sized pieces, ppm will tell you how many of those pieces would be the solute. So here's an example. Let's say we have 500 milligrams of solute, and we'll divide that by, let's say we have 2 kilograms of solution. So if we divide that, that gives us 250 parts per million, or ppm. Sorry, there we go. Okay. And what that says, again, is if we have this 2 kilograms of solution, which would be about 2 liters roughly, if you were to divide that into 1 million equally sized pieces, 250 of those 1 million pieces would be this, whatever the solute happens to be. Parts per million. This is useful for measuring very, very low concentrations. For instance, if we're measuring pollutants in groundwater, oftentimes they're measured in parts per million or even parts per billion. Okay, what else do we have? We have 2 more. We have percent by mass, and this is simply the mass of the solute divided by the mass of the entire solution. And then you multiply that by 100, and the unit here is percent. So this simply gives us a percentage of the solution that's made of the solute by mass. So again, let's say we have, the other thing here is that the units need to match. So let's say we have 25 grams of X, and it's dissolved in 2,500 grams of water, and then we'll multiply that by 100. So we'll put this in parentheses. Again, you divide 25 by 2,500 in this example, and then that answer is multiplied by 100, and that would give you 1%. So that tells us that in this solution, by mass, 1% of the solution is made up of whatever the solute happens to be, this chemical X. Finally, we have percent by volume. Percent by volume works just like percent by mass. The difference, we're doing volume instead of mass. And this is often useful when both the solute and the solvent are liquids. Liquids can be dissolved into each other, and that's when this can be useful. Again, for an example, let's say we have 500 milliliters of X, whatever X happens to be. And this will go in parentheses again. And we'll divide this by, let's say we have 5,000 milliliters. That would be 5 liters of solution. And then that will be multiplied by 100. And when we do that, we end up with 10%. So again, what that tells us is that by percent volume, this particular solution is 10% solute, excuse me, and 90% solvent. So that's concentration. And again, concentration is a way of describing solutions in terms of how much solute is dissolved in the solution or in the solvent. It's a way of quantifying, of describing, using numbers, characteristics of a solution. Okay, try the practice problems and do your best.